Hello everyone, this is David Matkin, and this is a short video to introduce the concept of time value of money. Time value of money is a concept that we use in financial management and finance to help improve decision making whenever we have financial implications that are not all in the present. They may affect future activities or future investments, or we are going to make a decision in the present to do something, but it's going to have ramifications on our budgets and cash flows well into the future. Sometimes we know cash value up front, like how much we would borrow to get a mortgage or a car loan or something, or maybe how much money we have to invest. And the future is unknown to us, or the future is at least has some various possibilities, and we want to be able to model or evaluate what the impacts of the present cash amount will have on the future. So that could be how much we'll have to pay to repay a loan, or how much we should ask somebody else to pay to repay us if we have loaned them money, or how much our investment could grow to over time. What if we left it in for the investment in for 10 years, or if we left the investment in for 20 years? What would the effect be? What would the difference be there? Or other times we know something in the future. Say we know we want to save for a home, or a large investment, education, or retirement, and we know we have a certain dollar amount that we've projected for 10, 15, 20 years into the future, maybe even more, and we want to know how much needs to be set aside now and say every month or every year. So these are very difficult questions, and they require a set of calculations that a lot of people don't find very intuitive. And so we're going to try and help you build that intuition here. So let's start kind of jumping right in. We'll work on some terminology and some calculations along the way, but this is just to introduce kind of the logic of a time value of money. And we'll start with the questions that are up on the screen. You may have already read them. If you want to, you could pause the video and look over these questions. All three of those questions, A, B, and C, they're all asking the same question. Version A may be more intuitive for most of you, and that's kind of how we'll frame a lot of this. But if you want to, I'll just read it. What will $10,000 be worth after 40 years if the $10,000 grows at 8% per year? So this is a pretty straightforward kind of question, which is a compound growth question of taking a certain amount of money, $10,000, and investing it over a given period of time, 40 years, and growing at a certain interest rate. And the question implies a certain kind of sequence over time, like we are at a starting position and we're looking out into the future, and we can imagine this investment traveling through time and thinking about what its condition will be at the end of that 40 years. But we can also rephrase the question. Version B says, what future dollar value is equal to $10,000 today if the future is 40 years away and the required rate of return is 8% per year? Well, that's asking the same question. Once again, it wants to know what that value will be in the future, but it's not framing the question as something where we would observe this moving through time. It's sort of emphasizing this idea that future value, whatever it might be, is equal to $10,000. It's not that the $10,000 becomes it. It is equivalent or equal to it, provided that those two cash flows are 40 years apart, and that the rate of return, or the effect of the dollar change in every given year, is 8%. So we're saying we've got these two values, they're 40 years apart, and 8% is what defines how much those values change every year. And so what is the value in the future that is exactly equivalent to the $10,000 today if we have this 40 years and 8% compounding annually? And C emphasizes this even further by sort of implying the equivalency of the $10,000 by saying, what is the future value of $10,000 in 40 years if the time value of the dollar is 8% APR? So what is the future value of $10,000? This is $10,000 in the present. We'll often drop the term present value in this situation because we don't want to say what's the future value of $10,000 present value. But it could say what is the future value of $10,000 today after 40 years. That'd be another way of framing it. If the time value of the dollar is 8% APR, APR stands for annual percentage rate. This framing of the question, a different version, is just once again emphasizing the fact that whatever future value that might be, that's 40 years out, it's equivalent to the $10,000 today. It is the future value of that $10,000. So that's where that term time value of money comes from, is we're looking at these two different valuations separated through time. So what we'll see here is, let me just delete this. So this is a visualization of the answer to this question, which is, here's the $10,000 in time period 0, before any time has transpired. And here's 1 year, 2 years, 3 years. This is the future value of that 10,000 after 1 year, the future value after 2 years, the future value after 3 years, all the way up to the future value after 40 years. So all of these future values all along this curve are all equivalent to this $10,000 in the present, but they're just different in how much time transpires. But they're all different by 8%. In fact, all of these values are also equivalent to this endpoint after 40 years. It's that they're in different time periods. So when we're in a different time period, we can't compare dollars equally. So the equivalent version of this value of $217,000 40 years into the future is $10,000 today if 8% defines the effect of each year. So here is the formula, the future value. That's what we're getting to here if we have a given of a present value of $10,000. How do we calculate the future value? Well, the future value is just the present value, which is 10,000. That's where we're at today. And we multiply by the growth rate per period. In this case, periods are annual, but it doesn't have to be annual. It could be quarterly or monthly or other kinds of time periods. And what is the rate? So it's 8% per period. And then we raise this compounding rate to the number of periods that we're going to compound it over. And so here I've got this formula set up where I just take the present value and multiply it by 1 plus the interest rate, which is this 8%, all raised to the power of the number of periods. And I've got 1 in here, so that's how much that's what the future value was 1 period into the future. And here we can just go in, and I'll just change this to 40. You can see this is what the future value of $10,000 is. So what is the future value of the $10,000? It's $217,245.